Recording in progress.
Yeah, comes on everyone. So this was the last thing that we read. Let's see one more question. We got a disk here with a cavity. Now in this disk, the current is flowing circularly. So we have circular currents flowing in the disk. The inner radius is A, the outer radius is B. And this is a current per unit radial length. Is equal to K. That means if you take a small length here, dx, the current will be K into dx. And we have a magnetic field which is equal to B naught R square, R cap meaning radial direction. The field is going like this. Find the force on the disk. Here, current flows in concentric circles.
What is the meaning of current per unit radian? Is it the ring or is it a piece?
Come again.
K is the current in the thin ring or in a thin piece?
Current per unit radial length. Now think about it. You don't know what is radial length and you don't know what is unit radial length. Exam में इतना ही देंगे रे. They won't explain you what is all that. Current per unit radial length. It's an easy one. So what do you mean by this? So let's say at a distance x, if you take a thin strip, this is what it means, Rajat. If you take this thin strip, the current in this thin strip will be k into dx. That's the meaning of radial length. Here the radial length is dx. Make sense? Then so we got a strip now carrying a current I. And how is the magnetic field? The magnetic field is radial. That means at any instant, if you look at IDL cross B, how much will you get? So DL would be this length. B is this. Both are perpendicular. So IDL cross B will give you a force in the downward direction, isn't it? So on this entire ring, the forces would be downward. So I, that is DL, and B is that way. So DL cross B, the force will be upward. So at every point, the force would be upward. So at every point, the force would be upward. So DL is along the tangent and B bar is in the radial direction. So when you do DL cross R bar, DL cross B bar, you are getting an upward direction. This is the force. So force on the ring would be I DL cross B. So here all these DLs also will add up. So that would be length is 2 pi x and B would be B naught x square. Field is B naught R square. And the force on the disk would be integral 2 pi B naught I integral x square. What is I? I is k dx, right? Pi k B naught x cube dx. Limits would go from A to B. Have a look at this. Is everyone getting why is the force direction up? Current is flowing radially and the B bar is perpendicularly. Maybe I will decrease the number of green lines here. Maybe now you can see more clearly. So here B bar is like this. Here B bar is like this. So B bar is like this. DL bar is like this. And the force is the black line. DL cross B. So DL is rotating towards B. You can see the thumb will point upward. So this ring will have a force in the upward direction. Clear with this? Next one. Yeah, we actually had to integrate first for dl and then we had to double it. But since all are in the same direction, I took the dl as 2 pi r. Technically, what you said is right. Clear? Next one. That got the meaning of the radial length, right? Torque on a current carrying loop.
So,
Right.
sir, you said something कि double करना था अभी. What can you just repeat? कुछ double करना था जो हमने नहीं किया.
No, nothing else. You understood this thing, right?
Yeah.
Yeah, but that's it. That is important. Don't get confused yourself. You understood
Okay.
this. It's someone else's doubt. We both are clear. Listen. You guys are too curious about everything, right? They were saying this DL is for a small segment, right? So technically, I should integrate first for the ring and then integrate further all rings to make it a disk. बस इतना ही था. That you also know. Anyways, next thing. Now, if you have a force, you'll also have a torque. You can have a torque. So let's say we take a rectangle here. This is your B bar. And let's say current I is flowing through this loop. Let the length of this thing be L. Let the breadth be B. So this is a rectangular current carrying coil. Now, if you look at the forces acting on this, look at this thing. So in this, the current is I this way. The magnetic field is B this way. So if you do I dl cross B, the force would actually be downward. On this, the current is I this way. Current is I, current is I. And if you look at the magnetic field here, this is B bar, this is B bar, and this is B bar. And when you do IDL cross B, you will realize this force is acting this way, this force is acting this way, and this force is acting this way. Where this force would be I into B into capital B. This would be I into B into capital B. These would be ILB. These would be ILB. So the two lengths which you have, both the forces will be pushing, they're trying to compress the whole thing. So if you look at this in the side view, you will see there is one force acting here, IBB, and this one force here, IBB. And the forces along the length will cancel out. Is this making sense, everyone? Are the directions clear? Should I show the directions again? I'm unable to draw this thing in 3D actually. So here the current is I, this is B, these two are perpendicular. So when you do IDL cross B, the force would be downward. So that would be into the plane. Is that making sense? Similarly here, when you take the force,
So how is the force into the plane? It should be vertically downward, no? I is into the plane.
so this is B bar here. So how is the force here?
Upwards.
So here it is up the plane, but there it is into there is a problem for you.
No, what I'm saying is कि I is behind the plane now.
यहाँ पे here it is upward, there it is downward. It's a problem for you.
It is not downward, it is into the plane. How is it into the plane?
Into the
It should
waiver
be
here.
vertically down. It should be vertically downwards, no? Even at that point.
ठीक है, you understood now. That thing is fine. I won't say into the plane. They're downward. Happy.
Happy.
Upward. Happy. There.
Yes, sir. Very
These
good.
directions are clear, everyone. So, and these forces will cancel out. Let's call it F dash and F dash. So if you see, the ring is actually being compressed. Sure, everyone. Now, if you see, these things will create a torque. So if you take this angle as theta, this length would be L by 2 and this length would be L by 2. So here the net force is 0, but torque is not 0. So if you calculate this, torque would be I into B into capital B, L by 2 sine theta into 2 times. So we get I into LB into capital B into sine theta. Let's have a look at this. Then we can combine this. So we get torque on one loop is I into LB P sine theta. So that is nothing but area of the loop. Now torque on the coil would be N into IAB sine theta. N is the number of coils or number of turns basically. So if there are 100 turns, the whole thing will get multiplied into 100. So this quantity can be written as mu b sine theta. This is given by mu cross p, cross product, where this mu is nothing but number of turns I into area. This is called magnetic moment. But remember this is valid only for uniform field. And if you look at this is similar to dipole moment. In dipole moment, what is torque? Torque was P cross E. So here P was your electric dipole. And E was your electric field. So if you see, there's a lot of resemblance here. No, coil is not a solenoid, meaning at the same point you just take multiple turns. The solenoid will have thickness. In our case, it is simply all the coils are at the same place. You can say solenoid with zero length. You just compress them at the same place. So if you see the formulas, they look quite similar. We'll compare that in the next page. But here, one more thing, when we talk about area, what is area vector again? So A bar is your area vector. Now, the important thing is how do you take the direction? So direction of the area vector is taken by right hand rule. So curl of the fingers is along current. Thumb gives you the area vector. Meaning example, let's say if you have a coil like this, and if a current I is flowing like this, so if you use right hand thumb rule, this is going anti-clockwise, so area vector is this, out of the plane. So like this. Area vector is always out of the plane. Just think of like this, na? A cross B, remember cross product which we did in vectors. A cross B was what? It's a vector out of the plane. That's an area vector, isn't it? A cross B gives you the area of a parallelogram. So same thing here. So N is the number of turns, I is the current, A is the area vector. So A bar ka direction is depends on the current ka flow. The current is flowing in the opposite direction, then you rotate in the other direction. Have a look at this. Then, so there is a main formula there. So torque on a coil is mu cross B and mu is NIA. Now, if you take this coil, the work done by the torque is integral torque d theta. When you go from theta 1 to theta 2, this would be integral mu b sine theta d theta theta 1 to theta 2. Sine theta can tell you minus cos theta. That will be minus mu b cos theta 2 minus cos theta 1. So work done by external force, since we're rotating the coil slowly, this would be 0 since so if you rotate that coil slowly from theta 1 to theta 2, the work done is this. So all the energy must have gone to potential energy. This would be minus mu b. We have done the same thing in dipole. Electric dipole, we found the potential energy like this only. U of theta 2 minus U of theta 1. Then we choose theta 2 is equal to 90 as reference. So U of 90 would be 0. So you end up with U of theta is equal to minus mu b cos theta. Therefore, the potential energy is given by minus mu bar dot b bar. Do you guys remember this in dipole? In electric dipole, the potential energy was minus p bar dot e bar. That's what I said. The formulas are exactly same. P ka place mein you'll get mu and E ka place mein you'll get B. This is the potential energy of a dipole. This is your next formula for this thing. Again, you'll encounter the same problems in bar magnets. Huh? There we will call it M bar. Ideas would be exactly same, the same torque and everything. But remember, all these are valid only for uniform fields. So this is A bar. This is A bar. This is A bar. This is B bar, B bar, and B bar. So here theta is 90 here. Torque is maximum. Energy is 0. Here torque is 0. U is minus B, stable equilibrium. Here torque is also 0, but potential energy is plus B, plus mu E, mu B. This is unstable equilibrium. There, have a look at this. We had similar formulas in electric dipole. Hey everyone. So these are the three main formulas. Torque is mu cross B, mu is NIA. Potential energy is minus mu dot B bar. Let's see a question. We have a current carrying loop whose plane makes an angle of 30 degrees with the magnetic field. It is rotated by 30 degrees towards B bar. Current is I. The radius of the coil is R. It's a circular coil. Find the work done by external force. If you didn't mention anything, we'll assume it is rotating slowly. So we have a coil here carrying current I. This is B bar. Mass M. Radius R. Find time period for small oscillations. If you hear the word stable equilibrium, done, you'll get SHM. All the small questions, I'm keeping them together. So we have three coils. So they're carrying current I, and carrying current I. Three circular coils along XY plane, YZ plane, and XZ plane with a common center. Radius is R. Find the magnitude of mu net. Find the net magnetic moment. Remember, just like dipole moment, mu bar is also a vector. It just adds up like a regular vector quantity. Let's get all of them. Try them all. I'll give you 2 minutes and I'll show you. Each one is one small question in mains of bits. I R square B by 2. Okay. Be careful with the word. Huh? This word is a trap. The plane makes an angle. Area vector makes an angle. Completely two different words. So what he's saying in the first thing, the plane makes an angle of 30 degrees. So this is the plane. This is your B bar. He's saying this is making 30 degrees. That means the area vector is actually making 60 degrees. So the initial angle is 60, not 30. The plane is making 30, not the area vector. So area vector is making 60. Then you rotated this by 30 degrees. So this guy became like this.
Sir, उसमें लिखा है कि it is rotated by 30 degrees towards B, which means it should become like in the plane with B now.
So it will be like this. It's rotated towards B bar.
The
A bar.
plane of the ring is no. The plane of the ring is towards B bar, so it should become parallel with B bar.
Plane of the vectors rotated by 30 degrees.
B bar, so it should be like this. No?
I got your point. Let's write area vector. You could say that the area vector is rotated by 30 degrees. I wanted you to understand both are different words. So what you're saying is right. If I had taken that way, that would be confusing word. Actually, you can say that. Okay, let's keep it as area vector. So the main idea was that initially it was not 30, it was actually 60. So area vector is something, plane of the coil is something else. Generally, when you say the rotate now, people generally talk about area vector being rotated. Because when you say plane of the coil, you say this is rotated this way. Someone will come and say, ye bhi plane hai na, this is also rotated towards this way. It starts becoming confusing, like you can argue however you want. So generally, don't bother. When someone says it is rotated by 30, we are talking about area vector only. And then you're done actually. What is initial potential energy? So U initial is minus mu B cos 60. So U final is minus mu B cos 30. So work done would be U final minus U initial. What about the second one? System is in equilibrium and find the time period for small oscillations. I know that I can be, you can assume however you want. I'll just do one thing. Area vector is this way. Current is I. System is in stable equilibrium. If it is not in equilibrium, bring it to equilibrium. Mu would be N into I into pi r square. Clear, Aryan? Get B and C. Find the time period and the mu of the system for the three circles. Look at the second part. So this is mu bar. This is V bar. So twisted by small angle theta. So this is SH only for small oscillations. This is B bar and this is theta. So we get torque is equal to mu B sine theta. This would be minus I alpha. This would be mu B theta. For large angles, it's an oscillating motion. We get alpha is equal to minus mu B by moment of inertia into theta. I is mr square. It's a ring, so it's m r square. So you're done. So time period will be 2 pi root over I by mu b. Mu would be n into I into pi r square. Yeah. And for the third one, you'll have three vectors basically: mu bar, and mu bar. The mu net magnitude will be mu into root 3, where mu is I into pi r square. If all three circles are in three different planes, the three vectors will be in three different directions, x, y, z. So it's like mu I cap, mu j cap, mu k cap. That I can't be sure about I j k ka exact direction. What is the axis of rotation? This line, right, along b bar, na? That area vector is oscillating about the b bar. It's a line passing through the center and perpendicular to the plane of the circle. So it's a m square. Clear with this? Any doubts on this? Please ask me. So there, you hear the word equilibrium, then SHM is always there. Let's see one more. Suppose if I have coils like this. One more thing I forgot to write here. So this thing, right, even though we derived for a uniform field and for a rectangle, added for uniform B and any coil, like coil of any shape. In a plane. So even though I derived this for a rectangle, I could have taken any random amoeba shape. So idea was this: if I take a random amoeba shape, I can take this as small rectangles, isn't it, while integrating? And when I add it up, I'll get the area of that edge thing only. But the main catch is it should be in the plane. Because if it is not in the plane, how will you define area vector? You can't use right hand thumb rule. So this is valid for anything. So this question, right, the coil is out of the plane. It's a find the magnetic moment of this loop. Hmm. How do we get this? Yeah. So the idea in these kind of questions, right? You introduce two wires here, one carrying I like this and one carrying I like this in the opposite directions. So when you treat like this can be split into two loops. because if the current is going in opposite direction, it is fine. Mathematically, it is the same thing as if there's no current in the loop. So I have chosen one loop like this and one loop like this. Now the main idea here is to get a current loop. So that created one loop. This also created one loop, and my system is still intact. So for this guy, it will be out of the plane, and for this guy, it will be upward. This guy would be this way. How much is that? I into a square j cap. That would be I into a square I cap. So the magnetic moment of this system is I a square, and number of turns are n. Fine, if I give you that, would be I cap plus j cap. Is that clear? So the main idea there is you need to create two loops. You can't use the formula when the plane is out of the plane is twisted out of the plane. How will you do this thing, the cube one? So cube may, you can see how the wire is going. Wire is not going throughout. The red one is a current wire. It's forming a loop, but the entire loop is again twisted out of the plane. Find the magnetic moment of this. 0. Okay. Someone got I plus j plus k. Someone got 0. Try. I'll give 30 seconds. Think about it. The idea is the same. You have to make loops. You can't directly apply the formula for this guy. इसमें लेना कैसा है coil? So we'll assume one here. To compensate, I need to keep one more here. I will assume one here. To compensate, I need to keep one here. Why am I getting feeling it will cancel out? I'll keep one here, and to compensate, I'll keep one here. So I'll have to assume multiple things. So now we have one coil, which is this is constructed by one green one and one black one. The other one this is that upper one. This is constructed by that orange one. Then this side one नहीं cancel नहीं हो रहा है, I guess नहीं हो रहा है. We have to use that orange one again. And there is a black one. Yeah, they're not cancelling out. You can see. So everyone will have two red ones. So these guys will share a green one. These two guys will share an orange one, and these two guys will share a black one. So we created loops. So this guy, it is going into the plane. Now I need to define my x, y, z. So I will choose this as my x. This is my y, and this is my z. It depends how you take your eyes. It's magnitude to same aega, but if I choose the directions here, so this guy, it is going into the plane. So this is minus k cap. This guy is j cap. So this guy is minus I cap.
So the top one is minus j cap.
Minus, वो भी minus है. So magnetic moment mu will be I into a square into number of turns, length is L square, minus I, minus j, minus k. Yeah, minus j. Got this? So there. So this, whenever you have, the current wires out of the plane, put extra wires, and because if iron flowing opposite directions, it is as good as having a zero current. Clear with this model? That is one.
If I
Hmm.
introduce more wires like at the back also,
Back also. Okay, then क्या करोगे?
why is that wrong? Because I'm making
नहीं, wrong नहीं है, but
like simultaneously the front wires are there as well as the
no, but how will you make a loop? Then you're saying you'll keep here also one unnecessarily, right?
yes sir.
Then unnecessarily have to add here also one. Then you're making a loop out of it, right? This will cancel it automatically. See, what you're doing is simply you created a cube, imaginary cube with zero current, isn't it?
Yeah.
If you just create an imaginary loop like this, and if you say there's an opposite current here, so ये तो cancel हो ही जाएगा system में.
No, but the wires I've introduced at the back will cancel the ones at the front.
But to compensate that wire, you must have introduced something else, right? That will form some other loops. Try करके देखो ना. You show me that thing. You will get the same thing.
Okay. Yeah.
Because when you put a loop outside, some wire will be left out. To compensate that, you'll put some other wire, so that will create a loop. Main idea is to create a closed loop. See here, when I said the green ones and the black ones and the orange ones, you have to make sure you have to use everyone. You can't leave anyone out. वो important है. You can't say like, I will use the black one here, but यहाँ पे मैं black use करूँगा. And then you'll be stuck because you kept extra black wire left out. No. So mean that. So when you're taking wires, make sure all the wires are being used everywhere. End of the day, all the wires must have been used. So try करके draw करके देखो. If you're not getting the, let me know. The next one. We have a solid sphere. Mass m and radius r. There are n turns here. Along the, what do we call it? Diameter नहीं है ना? ठीक है, along the horizontal biggest circle, whatever. There's n turns along the center. What do you say? Diameter only?
Equator.
चलो ठीक है, not इक्वेटर इज टू बिग अ वर्ड रे, वो प्लैनेट के लिए आ जाएगा ना. जनरली दैट इज द फीलिंग. सो ठीक है, इक्वेटर डाल देते हैं. एंड ईच कॉइल इज कैरिंग करंट है. इट्स अ सॉलिड स्फीयर. The ground is rough, and you also have magnetic field B in the, B is this way. I'll just keep it here. B bar is horizontal. Find the acceleration of center of mass, friction, and angular velocity as function of theta. So this thing will start rolling on the floor. This is a no slipping condition. Huh? Meaning after some time, this is what you would have noticed. The coil would become like this. The area vector is rotating. So this will have acceleration of center of mass. This will have alpha and omega. This will start rotating. So there's a torque, right? Mu cross B. Torque will be which way? Into the plane, isn't it? Mu cross B, torque direction is into the plane, meaning if you put your thumb into the plane, the rotation is this way. System is being twisted into the clockwise direction. So this thing will actually roll forward. That's it. Once you got the torque meaning there, it is only then basic rotational mechanics question. Draw the FBT, start solving. Try, I'll give you 2 minutes. And this is not new for you guys. You have seen something like this. Maybe our words I'm using a little different here. Where did you see this? Yeah, the question. Electromagnet. Yeah. Half solid sphere, positive, half negative. Idea was the same. This was also actually a dipole, isn't it? You can take the dipole at the center of mass. This was a P bar cross E bar. So draw the diagram in the intermediate position at an angle when it is rotated by theta, and then see. Take theta with the vertical, because you're saying angle rotated. See? What are the forces acting on the body? Now that magnetic force, there's no magnetic force, but there's a magnetic torque. This is A bar. This is B bar. I took this as theta, so this is 90 minus theta. Because the question was find the function of angle rotated, so I'm taking the angles with the vertical. Torque is which way? Torque would be this way. So torque would be at any instant mu b sine 90 minus theta. Torque is mu b cos theta. Mu would be n into I into pi r square. And what are the other forces? So if I just draw this thing, again a small one. Friction. Now I don't know how is the friction, so I will just take it forward axis. There's only one horizontal force. Mg. Normal reaction. Now don't forget, even though there is no magnetic force, there is a magnetic torque. It's like a couple, right? If you observe, the torque on a coil is like a couple, and torque about any axis for a couple is same. So it doesn't matter about which axis you take. And you know what is our favorite point? We always take the bottommost point. If you take torque about A, friction ka torque 0, N ka torque 0, Mg ka torque 0, the only guy left is torque magnetic. That will be equal to Ia into alpha. The torque magnetic will be mu b cos theta. I about moment of inertia will be 7 by 5 mr square alpha. Parallax theorem. So we get alpha is equal to 5 mu b cos theta by 7 mr square. From here we'll get acceleration is equal to r alpha 5 mu b by 7 mr cos theta. And if you see here, the only force acting on the system horizontally is only friction. F is equal to ma. They can ask you even minimum coefficient of friction also. Then you let F is less than equal to mu mg. And then from there, you'll get mu also. Now, once you got this, you can find omega. So alpha is nothing but omega d omega by d theta 5 mu b by 7 mr square cos theta. Integrate on both sides, you end up with omega square by 2 is equal to 5 mu b 7 mr square. That would be sine theta. From here, you'll get omega also. Check. 7. Aryan,
Is it
did I
wrong?
go up?
Center of
Are
mass.
center of mass ले
Axis.
सकते हो. If you take center of mass, then friction का torque भी include करना पड़ेगा. Yeah, then you will take torque due to magnetic is this way, friction is this way, so they'll subtract, na? Then you'll let again F is equal to ma, and then you have to substitute there. Same आएगा. It's not wrong. You can take torque about either the center of mass or any bottommost point. Bottommost point is safe, like because you don't want to bring the friction every time. If the question had been slipping, na, I couldn't have done this about the bottommost point. Then to chupchap I would have taken center of mass. Have a look at this, everyone. The theta I was taking with the vertical. Array, when you say mu cross b, what is that sine theta? Theta is the angle between a bar and b bar, right? So that way, and here we have taken the angle rotated with mu cross b. Clear with this?
मैंने थीटा भी उल्टा लिया.
ध्यान रख लेना बस वही है. Let's see one more. Any doubts on this? Please ask me. Next one, we have a coil. This is your x-axis. This is your y-axis. The coil is carrying current I is equal to 2 amperes. So this coil is hinged along this line. This is axis of rotation. Getting it? So we have a ring of mass 2 kg. Radius is 1 meter. I hope you're getting the meaning of, axis of rotation is fixed. For example, if you look at my screen, if I take this book here, right? And if I say, I'm going to touch here, I'm going to touch here. So these 2 points I'm fixing. Getting it? Now the only way book can rotate is like this, isn't it? You're restricting it. Matlab, this book, right? If I say these 2 points are fixed, kuch nahi kar sakte ho. It has to rotate about this line here. It has to rotate this way. There is no other option. Getting it? If I say I'm fixing here, now these are some standard ones. So now this is your axis of rotation. So axis of rotation is your choice. You can just fix up any 2 points and say I'm going to rotate only in this way. You need not take a standard axes that we know every time. And in this region, you're applying a magnetic field B bar, which is 3I minus 4J plus 5K. Getting it? And neglect any gravity here. So the question is, the ring is restricted to rotate about to I plus J. Matlab that axis of rotation is there. ये vector 2i plus j. Initially, the thing is in the xy plane. Find initial angular acceleration. So the moment you switch on this field, this thing will try to rotate. So find the initial angular acceleration. It's a good one. Let's see. Angle of axis of rotation with respect to x or y axis. What are you talking? I gave you 2y plus j. What else you want? I gave you the vector only. How would we do this? See, the formula is still valid. Torque is equal to mu cross B. So initially, the mu bar is coming out of the plane. Let's see.
By taking the torque, we have to take the magnitude in the equation, or we have to take along with the I cap j caps, whatever is coming u plus b.
So what do you think?
Vector.
So do it, na then.
But axis is different, so that is not coming use anywhere.
And so then you can't do that then. See, you figured it out. So what is the question exactly? You're asking me to tell the answer, right? Indirectly. Is that what you're asking me?
But torque to the couple is same across any axis.
Yeah, like God. You're restricting it. Matlab, if you let the ring rotate, it is same. But you're not letting the ring rotate only. Now see, this is your mu bar. Mu bar will be how much? NIA, this would be K cap. Current is going in the XY plane here. So you guys forgot something. You guys don't know how to take component of one vector in another vector. So we get torque is equal to mu cross B bar. So mu will be NIA. N is 1, I is 2, radius is 1. So 2 pi K cap cross B bar, which is 3i minus 4j plus 5k. Do the cross product. So we get torque is equal to 2 pi to 6 pi K cross I would be J. 8 pi K cross J would be I. K cross K will be anyway 0. K cross J would be minus I. So this is plus. So if you take out basically 3 pi, 2 pi, you are getting 3i plus 4j. So meaning if you had not kept any restriction, the system would have rotated about this axis. Now, because you are restricting it from moving, this is what was happening. And we know if you have B bar like this, and if you have A bar like this and theta, you learned this thing, A cos theta B cap is nothing but A bar dot B bar by mod B bar. So basically component of one vector in the direction of another vector. So this is your total torque, you're getting it. This is your net torque. You are trying to apply a torque in this direction. Are you getting it? The system would love to rotate in this way, but you're restricting it. So then you should take torque. So component of torque along axis of rotation. So that would be torque about the axis of rotation would be torque dot the axis of rotation is 2y plus j by mod of 2y plus j. Is that making sense, everyone? The system is trying to rotate about 3i plus 4j, but since you restricted to rotate about 2y plus j, only a component of torque will make it rotate. The other component will become perpendicular, isn't it? So it can't rotate. Meaning, aisa socho. For example, now this book is there. This is my axis of rotation. You can see the edge. Now, if I apply force like this, the book will rotate. But what if I try to apply the force like this? Am I not applying torque? If you look at there, F is this, perpendicular distance is this. The book is actually, if I had left it like this, the book would have rotated like this. But the moment I say this is my axis, you are restricting it from rotating. Torque hai, but rotate nahi ho rahe. The hinges are stopping from rotating. Making sense? So what if I apply force at an angle like this? So there'll be one component which is pushing this way, one component pushing this way, and one component rotating it. So you take the torque only along the axis of rotation. Only that is responsible for rotation. Just think of like forces. Are
You've taken only magnitude. We have to take vector also.
you taken what? Can you come again?
I've taken only magnitude for torque. Tau dot 2i dot j will be a number and divided by magnitude.
Yeah, magnitude आएगा and B cap डाल सकते हैं ना रे God. I wrote ना B cap.
Is it necessary or not?
You tell me ना. Why do you ask me everything रे? तो exam में क्या करोगे God? I'm showing you ना. Where am I running away? I'm explaining right. You don't have patience only. You want confirmation before doing each and every step. Exam में how will you do the exam में questions? Whom will you ask for confirmation every 2 steps? Do it na. Do it till the end. Get a wrong answer right, and then you can understand. Okay, this is how I went wrong. Problem क्या होता है ना, exam में you'll never have confidence to go one step ahead. You'll always get stuck. So once I got the torque about that axis, this will give you the magnitude. I agree with you. There's no doubt about it. Because already again, I just want torque about the axis of rotation. How much is this? No, everyone, I'm telling you seriously. When you're asking now, you're not in 11th standard anymore. Juniors now who people who joined, they can ask like that. Because they still don't know, right? They came from school right now. What you guys are not realizing is, ask me doubts. First you try, get a wrong answer and then ask, sir, why am I wrong? वो सही होता है. That way you will learn what you understood, what you did wrong. But you write one step, sir, do you think this step is right? Yeah, it is right. Okay, then I will do the second step. Sir, is this right? Yes. Okay, then I will do the third step. No, this is bad. If you wait for confirmation for every 2-3 steps, you're telling your brain, boss, I don't trust myself. My knowledge, I don't trust. Only when someone says, yes, I'm right, then I will do. And I have seen some brilliant friends in my IIT who did nothing in life. Why? They want confirmation for every damn thing. Exact plan, pura 100% perfect hona chahiye. Condition should be perfect to do a startup. Investors should come and say, Dekho, I'm giving you money, you do the startup. Everything should be ready, only then they'll do everything. These people are perfectionists. In life, if you have around 60 to 70% certainty, I think you should go ahead. People who wait for 100% confirmation, you're too late for anything. Even 90% is too late for anything. Anyway, so yeah, there we get the magnitude here. What is this? 2 pi 326 plus 4 by root 3. I hope I'm right. कितना था ये? 20 pi by root 3. You wanted direction, you can take 2i plus j by root 5 था ये. Yeah, root 5. Root 5. But like I said, this is a unit vector, so it really won't matter for us. Ishan, that's the reason you're getting sin 83. Oh, beach angle to le raha tha unnecessarily. You should have just taken this thing. Question still not over, huh? So now talk about this axis will be I about axis into alpha. So this guy would be how much? So if you want to take in the sort of direction, you can do that also. 8 plus. Did I goof up somewhere? I goofed up somewhere. This is 3j ray. लग रहा था कुछ तो weird है. This would be 8 plus 3, 11. So 22 pi by root 5. This much is there. What is I? What is I? Think carefully and tell. Don't tell me what comes in you first in the head. mr square by 2. Axis is in the plane of rotation. When will we get mr square? Mr square is if you're rotating about the central line passing through this and perpendicular, isn't it? This is the diameter. So be careful. मतलब पूरा question करके ना, you goof up there for a 2 my answer will go off. That is the sad part of this problem. So I should be, this is the axis of rotation about diameter. How many of you goofed up this part? How many of you thought I is mr square? Or how many of you actually figured out I is mr square by 2? How many figured out? 1, 2, okay. बस हो गया, substitute कर लेना, values आ जाएगा. Check it out. It's a good one. It's not a tough question, but you know, most people don't realize like you're getting a torque, but you give an axis of rotation. उनको समझ में नहीं आता यार, like, yeah, do what exactly? Because we're so used to writing, right? Whatever we get torque is equal to I alpha. We stop thinking like, you know, that it can also depend on your axis of rotation. Is this making sense? So if you want alpha na, so whatever magnitude you get, uska direction bhi yahi aayega, 2y plus j plus root 5. So that is a catch, Radhrit. If you're taking direction, right, you get alpha ka direction also in terms of vector. If you just want magnitude, it won't matter. Okay? Yeah. Any other doubts? Clear with this? It's a good one. It's mostly based on vectors. The main idea in the question is that you have to take the component of vector along the axis of rotation. Just because you apply torque doesn't mean you'll rotate in that direction. It depends on your axis of rotation. Let's see one more. Let's see one more. This came in JEE exam. Huh? We had a ring like this. 2 strings are there. Let's call it T2. Let's call it T1. This is a string. Current is going like this, meaning I know some people can see in the reverse direction. So current is going into the plane here on the right hand side, and the current is coming out of the plane here from the left hand side. Samajh mein aa raha hai? It's going in and out. and you kept the magnetic field B bar like this. Mass is M and radius is R. Find T1, T2. Gravity is there. The ring will remain horizontal. Find T1, T2 in equilibrium. And ring is horizontal. JEE may they simply asked you which one is bigger, T1 greater than T2, T1 less than T2, both are equal. It depends on the direction of current. Is options tha. We will find T1, T2. Let's get this. This was a PYQ. System is symmetrical. Shouldn't T1 be equal to T2?
नहीं क्या समझ गया बस
मतलब वही है, the current is unnecessarily dancing there, the poor thing. इसका कुछ use नहीं है. You just ignored it. Like, you know, दाल में वो करी पत्ता साइड में निकाल के डालते हैं ना, like that you throw that current away. That is what the current will be thinking. Shit, I have no use here. It will rotate about the ceiling. Oh, what do you mean by that? वो body बहुत weird है. Rotate towards ceiling मतलब, you know, I'll assume it is rotating like this. Torque कैसा है gods? यहाँ पे area vector कैसा है? This is the area vector ना, mu bar. This is V bar, right? So mu cross B will be, it is getting twisted like this na. It is getting twisted like this. The axis of rotation is into the screen. So matlab agar, if the torque becomes too much, the ring would become like this. T1 will go up and T2 is pulling down. So exam it was easy to figure out. T1 will decrease and T2 will increase. But let's find T1, T2. mg plus pi VR by 2. Okay, that could be right. Try everyone. I'll give you a minute. Let's see. This would be your mu bar. This would be your p bar, mu cross b. So your rotation is which way? This mu cross b is rotating clockwise. So your torque, this ring is actually being twisted this way, which is mu b. 90 degrees it is. Now again draw the FBD. If you draw the FBD, the forces would be T2, forces would be T1, your own weight mg. On top of it, you also have your rotation this way, torque. Remember the torque due to magnetic is a, what do you call it? It's a couple. So यहाँ पे देखो अभी restriction ये है, as long as you keep it in this plane ना, you can take about any axis. But suddenly you come and tell me you are rotating about this some weird plane. Now see, both are perpendicular, both are having at an angle, right? And now you can't take torque about this axis is equal to full. As long as the axes are parallel, it is acceptable. Torque due to a couple won't change. But if you twist that axis and keep it at an angle, you can't do that. You have to take the components. I hope you're getting the difference between this problem and the previous one. So, but anyways, so simplicity, we'll just take torque about the center. So first thing, T1 plus T2 will balance mg. If you take torque about center of mass, that would be T1 into R plus torque due to magnetic, both are in the same direction, minus T2 into R must be equal to 0. So from here we'll get T2 minus T1 will be torque due to magnetic is mu b by R. Okay, na? Two equations, two unknowns. Add them, you will get T2 is equal to mg plus mu b by R by 2. And T1 भी आ जाएगा mg minus mu b by R by 2. So they can ask a question like this also. Find the condition if T1 becomes 0. So if you apply too much magnetic field, there is a possibility T1 can become 0. Yep. Clear? And what is mu? Mu is a number of turns. I didn't give you that. I into pi r square. You can substitute the value there. Easy? Main thing is that rotation ka direction you have to be careful. Next one. Any doubts, please ask me on this. Net force equation, we didn't include IB. There is no IBL, God. What IBL? It's a loop. Loop mein what is the projectile length? 0. There's no magnetic force. In a uniform magnetic field, in a closed loop of any shape, the force is 0. Clear? Next one. This next one is an important one. Comes in 3 chapters. Huh? So the idea is important. Problem is fine. So we have a tightly wound spiral. There, are you guys getting hypnotized? There. Now study well. I wish I could do some hypnotism like that and make people study. This is A. This is B. So this is a tightly wound spiral. And draw properly. N turns. The idea, the way we proceed with this, the idea is important. Remember that. You'll again encounter this in the next chapter only, and then again encounter an EMI. N turns where inner radius is A and outer radius is B. And current I is flowing through them. Find the magnetic moment of this. Find the magnetic moment of the spiral. Let's get this. The gaps are pretty tight actually. The thin wire and pretty tight. So listen to the idea here. Whenever you get a spiral, right, this is the thing. At a distance x, take a thin dx. So first we'll define number of turns per unit width. will be n by b minus a. So number of turns in this dx segment will be n by b minus a. This is how you bring dx into the picture. So in that small dx, you have this many number of turns. So the magnetic moment of that small dx ka coil will be the number of turns n by b minus a into dx. Current I, area would be pi x square. So mu of the spiral would be integrated this stuff. Mu I pi by b minus a integral x square dx going from a to b. So it will be mu I b cube minus a cube. You can further simplify that, but the main idea is this part, that the number of turns in the dx is n by b minus a dx, and from there you will get it. Yeah, right, Ishan. Easy. So that was the main idea. So as such, the question was easy once you figure out that part. The next one.
सर इन द फाइनल एक्सप्रेशन में mu spiral what will take mu I pi तो mu की जगह n होना चाहिए ना शायद वहां पे
Mu नहीं है वो n है, right?
वे ठीक है
But it is not continuous, right? If you have finite number of turns, then
Meaning that is the reason we have to mention this. It's a tightly wound spiral, so we can almost assume it to be almost circular. I know it's not perfect, but
even if
your
it
basic
to be circular,
wires are pretty thin.
even if you assume it to be circular, we have to. Is it right to take that we have n turns in b minus a width? So
Yeah.
one turn will be b minus a by n into n. So you have to summation instead of integration.
You have to make it problem. अरे उसमें logic problem क्या होगा ना? First of all, it won't even complete a turn, right? It's not a closed loop. It will become a problem that way. So we have to make sure like there are very huge number of turns.
But then if the wire is thin, then how?
Yeah, you can't solve then. Then you can't solve. So that is the whole meaning of tightly wound spiral. So we are assuming it's like there are a lot of turns and the wire is very thin. If the wire is thick, you can't solve. You don't have a way. Okay? So if spiral is given, assume this is the only way to do. Because the moment you say the wire is thick, the first problem you will come is that area of the loop itself is not defined now. Next one. Let's say we have a charged particle. Radius r. Q going with speed u. We have a ring here, lambda r, rotating with omega. We have a disk. Find magnetic moment of all these things. If something is going in a circle, it behaves like a current loop. It's a disk with Q and R, rotating with omega. Sigma is equal to sigma naught x for x less than equal to r. Surface charge density. So if a charged disk is rotating, it behaves like multiple current loops rotating. Uniformly charged hollow sphere. Find magnetic moment for all these things. That's when a charge rotating is as good as a current loop. And I'm sure some of you know the shortcut result. But then you'll get stuck with D. That's why I gave that. Let's get it. Plus Q and radius h. You should know how to integrate because something changes, you won't know what to do. So in all these 5 cases, find the magnetic moment. If a system is rotating, it behaves like a current loop. And for a current loop, we know it is I into pi r square. I'll just show you the first one. First was easy. We know something is going in a circle. This we did in current electricity also. So current I will be Q by 2 pi R by U. So this is Q into U into 2 pi R. So magnetic moment would be I into pi R square. So QU by 2 pi R into pi R square. QUR by 2. There. So get the current and finish it off. Now, can you do for the remaining 4? Let's get them. What is the second one? It's a ring. So I would be Q by 2 pi by omega. The mu would be I into pi R square. So yeah, Q will be lambda 2 pi R. So this would be lambda R omega. How to do C? Now, C that is not that straightforward to see because every loop at a distance x will have different charge. Try, I'll give 2 minutes. Let's do C and D together. I
Sir,
think you
for
can
C,
do D together. If D आ गया तो C भी आ जाएगा.
for C, is sigma constant?
Uniform disk I gave plus क्यों ना?
Okay.
Uniform disk है, uniform charge. This page here. Disk के लिए क्या करना था? Try. I'll do directly for D. So idea was the same for that. So take a disk at a center from X, take a thin circle here. Dx. So charge on this ring will be sigma naught X into 2 pi X dx. So current on this ring will be charge on the ring by 2 pi by omega. So sigma naught 2 pi will cancel, omega x square dx. That looks right. Then mu of this small ring would be I of the ring into area of the ring is pi x square. That would be sigma naught omega pi x power 4 dx. Then integrate this. Mu of the disk would be sigma naught omega pi x power 4 dx 0 to r. Sigma naught omega pi r power 5 by 5. Same thing you'll do for disk also. Disk ka case mein sigma will be q by pi r square. That would have been uniform. So that's how you integrate. So C ka answer.
So in D, what did I do wrong? I said to the entire working only. मुझे
Check
नीचे
करो ना.
three
What did you wrong? Figure it out. 3 आया मतलब it is huge difference. Clearly दिखेगा difference. देखो.
अच्छा ओके आई इंटीग्रेटेड I उसके बाद उसको A से मल्टीप्लाई कर दिया था
You have to take the mu of each loop and then you have to integrate. You can't integrate I. When you say I into area, if you take the total current area, what will you take? You can't take pi r square of the disk, na? It's pi r square for the loop.
हाँ यस सर समझ
So if you actually do for this would have been I'll show you that there is another faster shortcut that will answer. I'm interested in E part actually. Hollow sphere ka, how will you do with integration? There's a shorter way, matlab there is a a formula relation between angular moment and magnetic moment. With that you'll get the answer. But like what I did with D, if I do something with E also, I will say the charge density sigma is equal to sigma naught cos theta, where theta ka value varies from -90 to +90. You will die. You can't use that shortcut ka formula. So that's the reason you need to know how to integrate. So how will you integrate E ka thing and get this thing? Yeah, integrate, get it. Prove it with integration. Take 2-3 minutes, figure it out. You should be quite comfortable with integration, choosing elements and figuring it out. And this hollow thing is not the first time. First time you encountered this thing in center of mass, then moment of inertia, then electrostatics. This is the 4th time already. एक और बार encounter किया था fluid mechanics में. For projected area time, I calculated this. So this hollow sphere came multiple times. The moment I said hollow sphere, in your brain it should shine like how to choose an element. Previous disk here. Any doubts on this disk, please ask me. I could have taught you that shortcut first, but that will unnecessarily make you feel like, it is so easy. So let's see. How to choose an element for a hollow sphere. Remember this? This is how we choose elements. You will get a ring from there. That ring will rotate. So that ring ka magnetic moment aayega. That rings you have to integrate, you'll get a full hollow sphere. Idea is the same. At least till this part, the idea is the same. Think. Another minute and I'll show you. In exam, they would do that only. They will say sigma is equal to sigma naught cos theta. So you have a variable charge density on the surface. And then if you don't know how to integrate, you won't get a clue like what to do with it. Mains mein they won't ask you, but advanced mein they will. Let's see. QR ओमेगा बहुत अच्छा आंसर आ गया रे, अच्छा आंसर नहीं आएगा. So from this as a reference line, I'll take an angle theta. So if you take a small d theta, you will get a strip like this. There we got a strip like this, whose radius would be r cos theta, whose width would be r d theta. The area of the ring will be 2 pi r square cos theta d theta. So charge on that ring would be like I said, I'll do for something else. So here to sigma is constant. I'll change the question. Let's say sigma is equal to sigma naught cos theta. The standard one will get an answer pretty fast. I'll show you another way. So you're doing for sigma naught cos theta. So that would be 2 pi r square sigma naught cos square theta d theta. Then the current on the ring will be q of the ring by 2 pi by omega. 2 pi will cancel, sigma naught omega r square cos square theta d theta. Then mu of the ring will be I of the ring into pi into radius square again. This guy would be sigma naught omega pi r power 4 cos power 4 आ गया, cos power 4 theta d theta. So mu of this sphere, I change the question. I'm doing a non-uniform sphere. Now I'm not sure whether we can integrate this. Cos power 4 theta d theta, cos cube theta is still fine. Angles will go from -90 to +90. Cos power 4 को कैसे integrate करना है?
Sir, first you can split it into 0 to pi by 2 because symmetrical
into
होगा.
वो ठीक है, into 2 times कर लेंगे. Cos power 4
हाँ.
theta का क्या लेंगे limits?
And
Minimum
then
integration.
उसमें King's rule लगा के you have to displace it और उसके बाद एक formula होता है of
वो
a
always
sin
लगा
theta. Or you
So
can
there,
do that.
since you guys are experts on that, you'll get the answer from there. Done. Physics got over here. Should I take sin theta? Sin theta. Actually ना ये cos square theta ना would be even better क्या?
So like cos square into 1 minus sin square भी कर सकते थे, फिर like cos square sin square को
ये वो
sin to
बहुत
theta
हेड
कर
है को
देते।
बहुत हो जाएगा वो. I need a odd number. एक काम करते हैं, cos square theta लेके देखते हैं. Then this would be cos cube theta. Then this will be cos cube theta. This will be cos power 5. Cos power 5 is fine. I feel so. So that can be written as sigma naught omega pi r power 4 integral 1 minus sin square theta का whole square into cos theta d theta ना. Then put sin theta is equal to t. Then easily हो जाएगा integration. Making sense? उसका तो integration easy है. कितना आएगा वो? So 1 minus sin square theta का square cos theta d theta minus pi by 2 to pi by 2. Put sin theta is equal to t. This guy would be -1 to 1. 1 minus t square whole square. This would be cos theta d theta. So that will be dt. ये तो इंटीग्रेट कर सकते हो. कितना आ रहा है? 15/4 क्या? The substitute will get the answer. You're done. As long as it is odd numbers, it is easy to do. Even numbers, it looks pretty messy. Clear, everyone? So I'm not a pro in integration, so abhi dekh lo na. Itna to even I can handle. More than this, I hated integration. Clear? So this is how you do in case something is variable. But now, from all this, if you see, there's a general formula we get. Again, this is valid only for uniform charge distributions. You will notice for the particle when we did this, we got mu is equal to q u r by 2 if you multiply and divide by mass. So this MUR becomes nothing but angular momentum. So we get mu bar is equal to charge by 2m into L bar. This is the relation between angular momentum and magnetic momentum. So example, now if you have taken the disk, uniform disk plus q r rotating with omega, the mu of the disk would be q by 2m. What is the moment of inertia of the disk? Mr square by 2 omega. M will cancel. This would be q r square omega by 4. Directly you'll get the answers. Matlab, no need to integrate. Kuch nahi, you'll get the answers. If you take that hollow sphere also, which we did, M and R, and let's say charge Q, then you'll get Q is equal to Q by 2m into 2 by 3 mr square omega. You want solid sphere or 2 by 5 mr square omega. So if it is uniform, your life is easy. Directly put the formula, you'll get the answers. Mains level, bits level tak ho jayega. But once you go to advanced, they would play something like this. They will mess up the chart distribution. And then you'll start having issues. And what important, that thing which I taught you, remember this later on next chapter, I will ask you find the magnetic field at the center. Because when it is rotating in a loop, you'll get a current loop, and due to current loops, you get magnetic field. You can calculate B bar also. So when you see a hollow sphere, that integration ka elements and all should be quite comfortable. Have a look at this. Clear with this? So that is about the magnetic force ka chapter. This is the first part. So we had magnetic force, QE cross B, then we had IL cross B, and then we had torque. These are the three main things. The next part of the chapter is magnetic field, MEC, magnetic effects of current carrying wire. That is Biot-Savart's law. Now we will see how are you getting this magnetic field. Till now we said B is there and we did the problem, but how did we get that B ka value? That we will see how it depends on current and stuff. So that will be the second part of the chapter. After that we will do bar magnets and we'll do EM waves. We will finish off entire magnetism in one stretch. Okay, so that will wrap up for the day. And I'm not keeping that great also. So any doubts, anything else, you can stay back and ask. So next week we'll continue from here. So do start solving. If you're doing HC Verma, there are 2 chapters in HC Verma. This is one chapter called magnetic field. It has around 55 questions. You can do that. Again, I'm telling you, every chapter that we're doing, make sure to go through the notes. One. Second thing, please solve any one book. It doesn't matter. Any one book, take HCV